Every time you open Twitter, 50 ranked tweets appear in under 800 milliseconds. Here's the twist. Twitter doesn't build that list when you tap the app. It's like mail, delivered to your mailbox before you even check it. Today, we break down exactly how that mailbox works at 500 million tweets a day. The obvious way: when you open the app, query every account you follow. Follow 400 people? That's 400 database queries, merged and sorted, every refresh. Multiply by 238 million daily users checking their feed repeatedly, and you get 100 billion queries a day. At 100 milliseconds each, that's physically impossible to run. Think of it like this. You don't drive to 400 different post offices every morning to check for mail. But that's exactly what the naive timeline does, visiting every account you follow on every single refresh before showing you anything. In 2012, Lady Gaga and Justin Bieber each had roughly 30 million followers. When either tweeted, database CPU spiked 10,000x normal load in seconds. Pagers fired across the entire engineering fleet. This wasn't a bug, it was the naive architecture hitting its physical ceiling. Here's what nobody tells you. The fix wasn't planned, it was forced. During the 2012 Super Bowl halftime show, Beyoncé's performance sent tweet volume to 268,000 per minute. Twitter's pull-based timeline crashed live on the biggest stage in TV, forcing an emergency rewrite within days. The fix: flip the model. Instead of driving to 400 post offices, the post office delivers mail to your mailbox the moment it's sent. When you tweet, a worker writes it directly into every follower's timeline cache before they even open the app. The math flips completely. Pull needed 400 queries times 238 million loads, 100 billion queries a day. Push needs one write per tweet, delivered once, read forever after. Reads become a single Redis lookup, microseconds, not milliseconds, but pure push breaks too. Katy Perry has 108 million followers. Push her tweet everywhere, and a worker must write to 108 million Redis keys, synchronously. Delivery freezes for minutes. It's the mailbox problem in reverse. One sender, too many mailboxes to fill at once. Twitter's answer: hybrid fan-out. Under about 10,000 followers, push instantly. Mailbox delivery. Over that threshold, store the tweet once and let followers grab it directly at read time. Following 50 celebrities adds 50 lookups, not 500 million writes. When you open your timeline, Twitter does two things at once. Pull your pre-built cache for regular accounts, then fetch live tweets from celebrities you follow. Merge both, re-rank, done. One clean timeline mixing push speed with pull freshness. That mailbox cache lives in Redis as a sorted set. Key, your user ID, member tweet ID, score, timestamp. Twitter caps it at 800 entries, enough candidates for ranking without wasting memory. Reading your top 50 is one command, zrange. No sorting logic needed. Do the math. 800 tweet IDs at 8 bytes each is about 6.4 kilobytes per user. Multiply by 238 million daily active users, and Twitter runs roughly 1.5 terabytes of Redis just for timeline caches, sharded across a cluster, not one giant instance. Here's the clever part. Every tweet ID isn't random. It's a snowflake ID, encoding timestamp, machine ID, and sequence. Higher ID always means newer tweet. No separate timestamp index needed. Sorting your timeline is just sorting numbers. Because each machine generates IDs independently, there's no central counter to bottleneck on. 1,000 machines mint 4 billion unique tweet IDs every second. LinkedIn, Discord, Instagram, and Uber all copied this exact pattern. It's now the industry standard for distributed IDs. Chronological was Twitter's original model, newest tweet on top. Since 2019, that's gone. Now an ML model ranks roughly 800 candidates by predicted engagement before showing you anything. The goal isn't the newest tweet, it's the one you're most likely to react to. The pipeline runs in two stages. First, candidate generation. Pull about 800 tweets from cache plus celebrity lookups. Second, scoring. A neural network rates each one on predicted likes, replies, and retweets. Only the top 50 survive to reach your screen. This breaks everything you think you know. Scoring 800 tweets isn't simple math. Twitter's heavy ranker is a 48 million parameter neural network, scoring up to 1,500 candidates per request. It runs on GPU inference servers. CPU alone would need 10x more hardware to hit 150 milliseconds. None of this works without somewhere to store the tweets. Twitter used MySQL until 2014, then hit 500 million tweets a day and MySQL's sharding gave out. So Twitter built Manhattan, a custom distributed key-value store, purpose-built for this exact write volume. Manhattan uses a log-structured merge tree for heavy writes, plus consistent hashing so nodes join or leave without downtime. Writes replicate to 3 data centers at once. Tweet creation uses strong consistency. Fan-out uses eventual consistency since a 1-second cache delay is invisible to you. Put it together, you tweet, it writes to Manhattan and returns success in under 200 milliseconds. A Kafka queue triggers async fan-out. Workers push to follower caches, unless you're a celebrity, in which case nothing gets pushed at all. This is the stack running Twitter, now X, in production. Manhattan for storage, Redis for 1.5 terabytes of timeline cache, Kafka for async delivery, and a 48 million parameter model for ranking, delivering a personalized feed to 238 million people in under 800 milliseconds. This isn't just Twitter's problem. Instagram runs the same hybrid fan-out with denser graphs. Users follow around 500 accounts, not 400. Facebook, LinkedIn, and TikTok all use variations of push-pull hybrids. Anyone building a ranked feed eventually reinvents this architecture. In your next system design interview, say exactly this. I'd use fan-out on write for regular users to make reads cheap, with a hybrid read-time merge for high-follower accounts to avoid a write storm. That one sentence signals real production experience. The mistake most candidates make: they only mention one model. Pure push sounds elegant until someone asks about celebrities. Pure pull sounds simple until someone asks about scale. The senior answer is always hybrid. Know the threshold, know why it exists. Remember the mailbox? Push is the postal worker delivering mail before you wake up. Pull is you driving to the post office yourself. Twitter's real system does both. Mailbox delivery for most accounts, and a pickup counter reserved only for the busiest senders. That 800 millisecond budget is tight. Candidate generation and celebrity lookups take a slice. Heavy ranker scoring must finish under 150 milliseconds. Serialization and network hops eat the rest. Miss the budget and your feed loads slower than a refresh should ever feel. This exact pattern shows up everywhere. Notification feeds, recommendation engines, activity streams. Once you understand fan-out on write versus read and when to switch to a hybrid, you can reason about almost any feed system an interviewer throws at you. Twitter open-sourced this exact ranking algorithm in April 2023. You can read the heavy ranker code yourself. It's proof this isn't theoretical. It's the real system, serving 500 million tweets a day, right now. So next time your feed loads instantly, remember, nothing was computed in that moment. It was already sitting in your mailbox, delivered the second it was written, except for the one celebrity tweet the mail carrier grabbed just for you. The mailbox always beats the post office line. That's the whole story. Pre-compute what you can, merge what you can't, rank what's left. Now go explain fan-out on write in your next interview like you built it yourself. Subscribe for the next system design breakdown.